So we've seen what Dalton's law is, that I can combine partial pressures and add them to a total pressure. And we saw an example of how you might collect a gas over water. We're going to now take this example and work it out with some numbers. So Dalton's law was that these gases in a mixture behave independently, and also that we saw this picture where we have this bit of water vapor that we need to get rid of if we just want to do calculations related to oxygen. You're going to be given a table like this of water vapor pressures. This basically shows you that at low temperatures we get a small amount of water vapor above the liquid, and as we get closer to boiling over here, you start to see a higher vapor pressure. You know this if you put your hand over a warm pot of water, your hand gets kind of moist, and that's this vapor pressure that you're feeling. So this is going to be our vapor pressures of water, which I had colored green in this picture here. So if you have a setup like this and you collect your gas over water, is how we would describe that. That means that the pressure of the gas includes the vapor pressure too. So let's see how this breaks down. If we have this reaction, so this would be happening in that test tube that we can see over there. This is what you're going to have reacting. We collect 1.5 liters of oxygen, so sounds like a volume, over water, crucial, red flag goes up, at 27 degrees, 27.0 degrees Celsius, and a pressure of 758 torr. How many moles of oxygen are produced? And it might be worth looking at this as NO2. So I'm looking for specifically what part of this is the pink oxygen. Now, a couple things. I want to change my temperature before I forget to Kelvin. So that's 300.2 Kelvin. Now this pressure, it's important to note that this is the pressure of the whole thing. So this is the pressure, we could say total. And I need to get rid of that water pressure out of there because all I want is moles of oxygen. I don't want to take into account the pressure of the water. So in order to do that, I need to look at my temperature, which was 27 degrees, and find that on the table here. And this will tell me what the pressure of water is. So I'm going to take this total pressure and I'm going to subtract the pressure of the water, which is 26.74. And that gives me, once I use sig figs and round it, 731 torr, and that is now the 731 torr pressure of just the oxygen. So I got rid of the pressure of the water by subtracting it out, and that gave me the pressure just of the oxygen molecules. Since I'm going to be using the ideal gas law, PVTN, I know that I need to convert this to atmospheres. So look up that conversion. 1 atmosphere, 760 torr, and when I do that math, I get 0.962 atmospheres. All right, so that again is the pressure of just the oxygen, which is good because I want just the moles of oxygen. So if I'm solving for N, come over here, PV equals nRT. Solving for N means PV over RT equals N, so that's the equation I want to use here. N equals PV over RT. If I plug numbers in, pressure 0.962 atmospheres times volume 1.5 liters. Not a lot of sig figs there, right? So that's going to probably limit me at the end. If you want more significant figures, use a vessel that you can measure the volume more accurately. R is my gas constant, so again, that would be given, or something you want to keep on a cheat sheet nearby. 8.206 liters times atmospheres per mole times Kelvin, and then 300.2 Kelvin for my temperature. Watch your units cancel: atmospheres, atmospheres, liters, liters, Kelvin, Kelvin. My final units are going to be moles, and when I calculate that, I get 0.059 moles of O2. And again, I wanted just that O2, right? So I just want the moles of O2. I wanted to subtract out that water vapor pressure and then proceed with the ideal gas law as normal. So there's another example down here that you can try where we collect, again, hydrogen gas over water. This time it's at 18 degrees, so you'll have to come over here and find 18 degrees and what the partial pressure of water is there. So save that for class or practice it on your own and bring any questions you have.